Hello students, we are back with our next topic, electric potential due to a dipole. First one we have already seen on the axis of a dipole, which was Kp upon x square. Okay, this you have already known. Now what we'll do, we'll find it on the perpendicular bisector of the dipole, or you can say equatorial line. Suppose we have a dipole minus q plus q, and they are separated by a small distance, let us say L and L. Okay, that is twice L. Now what we need to do, we need to find on equatorial line. We'll make a equatorial line. This will be our equatorial line. Suppose a point is over here, a point is over here, or a point is anywhere on this equatorial line. We need to find the potential difference on this point. Suppose let us take at point this, name this point M. Okay, now what will the potential due to this electric dipole on point M? Okay, so we need to find V net. Let us assume this is 1 charge, this is 2 charge. So what it will be? It will be V1 plus V2. Okay, now let us say this is at distance x from this dipole. Okay, the perpendicular distance from this dipole is x. Then what will be the value of V1? V1 is, you know, kq upon the distance. What will be the distance? It will be it will be, as it is hypotenuse, it will be under root of x square plus L square. Okay, this will be the distance of this as it is hypotenuse. Okay, I hope you remember what is hypotenuse. Okay, x square plus L square, but here the charge is negative, so it will have negative sign. Okay, plus kq upon, what will be the distance over here? What will be the distance? It will be same, x square under root of x square plus L square, under root of x square plus L square. So what happens over here? The value and the quantities are same, so your ultimate answer will be 0. V net will be 0, which means that the electric potential on this point is 0. Okay, it does not mean there was no electric potential. It was electric potential due to this charge also and electric potential due to this charge also, but both were equal and opposite. So your total electric potential on this point will be equal to 0. Okay, let us assume this or see this when there is a plane. I hope you have copied this. Let us make a plane on this line. I'll have this line. Okay, this is minus q charge, this is plus q charge. I'll make a plane, equatorial plane. This is a plane passing from the center. This is a plane in this manner. If this is an electric dipole, a plane is passing in this manner. Okay, now anywhere on this point, okay, any point on this plane will be having equal distance from this point as well as this point. Whenever they are equal and opposite charges and having the equal distance, then the total electric potential will always be equal to 0. So electric potential at any point in this plane, a plane that is in perpendicular bisector of this dipole, then at each and every point the electric potential will be equal to 0. So you can also say it as equipotential surface. Equipotential surface, because the potential on whole of the surface is equal. That's why you can name it as equipotential surface. It is not that equipotential surface, on equipotential surface all the electric potential will be 0, but because here the potential on whole of the surface is 0, that's is equal, that's why you can say it is equipotential surface. And another thing, whenever it is asked in the exam what is the equipotential surface for a dipole, you can say it is the perpendicular plane bisecting the dipole that has the electric potential surface. Okay, and what is the potential on that plane? The potential on that plane is equal to 0. Okay, I hope you have understood it. Thank you, students.